Use your phone. How do you know?
So you have 2,375, but what you need to understand is we have 2,375 amp power at C100. But this same capacity, this same battery, if you are discharging at C20, the capacity it will give you is 2,200 amp hour. If you are discharging it at C10, the capacity it will give you is 2,000. So your C rate determines in actual fact also the capacity that the battery can deliver to you. So take a screenshot of that. I will explain that further in the class. Is that clear? Okay, let's move. Say bus bar.
Bus bar.
Say bus bar.
Bus bar.
Bus bar.
Bus bar.
Bus bar bar.
Bus bar.
So this is a bus bar. Remember, I was explaining to you bus bar. I mean, positive bus bar and negative bus bar. So this is the battery rack, beautiful one. So the bus bar, you have here the negative bus bar.
Oh.
You can either have maybe positive or it depends on the way you are doing your connection. The positive bus bar is down, the negative bus bar is what? Up. Now you know the function of the bus bar. I mean, to make your connection firm and easier so that you can always troubleshoot and make things look nice. Now look at this, the battery monitor, it has a positive and negative cable. So if you look at it also, you have the negative of the battery monitor here and you have the positive of the battery monitor here. Remember what I told you, all these drilled holes where you can put your what?
The cable and the boat.
Abi? The both are not. Very simple. So what makes up a bus bar? In the bus bar you will have like a ceramic insulated bar that you can place to hold it firm, and that is what. So this is the bus bar whereby you can have your battery terminals connected, positive and negative. You have your charge controller, the output also coming for positive and negative, and your inverter also, as the case may be. Is that clear? Yeah. Let's move forward. This is the charge controller. 80 amp 600 volt DC MPPT. These are the what? Isolators. So the way the array is designed is that we have 66 panels. So we have some section of the panels being supplied on this charge controller because the rating has been calculated. I've showed you how to do that to get what number of panels you can have in your charge controller. So this has been done. Same thing for this, same thing for this, and same thing for this. So you have the isolator. Why? So that if you need to carry out a maintenance on this section of the array, what do? You cut off the supply. Exactly. So it's very easy for you to carry out your maintenance. If you want to do for all, you cut off the supply of all of the night switch as the case may be. Then the next thing is to go to the what? Inverter. So you have the inverter. Now this inverter is an hybrid inverter that also has a what? Charger. Hybrid inverter. It also has a charger. You understand what it can do. You understand very well. The rating, what's the rating of this inverter? The rating is on this place is 4.5 kilowatts. You know, inverters, we have inverters, we rate them in kVA. But this, if you look at the rating, is about 4.5 kilowatt. Why kilowatt? Most of these tier 1 inverters, I told you, sometimes they rate them in kilowatt because they are taking kilowatt to be what? kVA. Because most of them have a very high efficiency compared to the other inverters that their efficiency is about 75% as the case may be. Okay, so you have a breaker. This is a breaker from so you understand. So maybe you need for protection between the inverter and the battery, as the case may be. Okay, so let me take this off. You have some other bus bars here. These are also bus bars. You can see bus bars now. So when we say bus bar, it's not something complex. You can always get this so that you can all have your termination neatly done. So we have a fuse. This is a fuse. This is a battery fuse. So we have a fuse. This is a fuse. There are different types of fuse. So you can use, for your protection, you can use a fuse or a breaker. You know the difference between a fuse and a breaker. You can actually reset your breaker, but your fuse, it depends. If it's a reliable fuse, you can do that, but if it's not, then you have to replace it. So here you have for communication, so you can see if it's up, you can see what you are generating. If there's a fault, you can actually know where the fault is and some other things. And here you have some control, for some controls and other things. Okay, so bring up your questions. Yeah.
Sorry, in connecting this the control box, is it connected to the inverter or the gyro controller?
So basically, what you have to do is, I told you one thing that is very important is for you to read the manuals of your equipment. Are you getting it? So it may not be this model. So if you are using a communication box, you have to read your manual and see where it's connected.
Sir, this there will always be serial inside or parallel.
Now it depends. But most times MPPT, they are parallel inside. If they have two position whereby you can have your PV input. So there are some MPPT charge controller that you have two inputs for your PV. So PV1, PV2. Two of them will be what? Parallel inside the charge controller, so that you can have more current.
What I'm saying is that this I'm not sure this will be connected to one. This will be connected to
No. This is a 9 kilowatt system. So one will serve as a master, the other will serve as a slave. So in the sense that if your load is 4, maybe you've set it that if your load gets up to 4,000 kilowatts, the second inverter should pick up. You have set the priority for that.
When the load is
but
reducing.
this, you know, all the current from the charge controller is going to where? So it has nothing to do with this. You understand? So that's why you have the bus bars, where you have all the positive and negative. I drew it in the class yesterday. The positive and negative of this. All the positive to one bus bar. Negative output to another bus bar. And that supplies all the battery.
In other words, I think this is it now.
Mm-hmm.
Yes.
This is it.
Yes.
This is it. These ones are the batteries.
No.
Yes, that's it.
Yeah, these are the batteries.
Last one. This is negative.
So you remember, come and see.
Yeah.
I can see
Look at it. So all the bus bars here for all this was now taken to the battery. Negative and what? Positive. So a mini bus bar was first used here. Look at it. 1, 2. Before now taking it
Just one
cable there. So the bus bars helps you to arrange your connection.
all these ones.
Yeah. So they now send it. Questions? Bring up your questions, please. Dayo.
Sir,
Yes, sir.
when doing sizing, we were putting consideration power loss.
Okay.
And now since we have different components, are all these components now also losing power?
Yeah, you remember when we are sizing for the system, I talk about performance ratio.
Yes.
Yes. For the performance ratio, I factor in cable losses,
The efficiency of the
inverter losses,
yes.
charge controller losses. So all those losses make it. We now factor that to now give us the system efficiency, which has been factored.
So, okay, if I want to design the place now, so that means I need to know all the components I will use.
Yeah.
Factor their losses.
Oh, that we started with the load analysis. You are already doing that. Everything has been captured. We started with the load analysis. That's the first thing. We look at the surge current, and it was after we got that before we now size our inverter. So in sizing other components, we now look at the system efficiencies. To look at the cable losses, these losses, these losses. Questions? You are not around yesterday.
Sir, as they've been using this battery before now, as they are not using it again.
Yeah.
What effect will stopping using it will have on the battery?
Yeah, definitely. If you can look at the battery monitor, the state of charge is very low, and it's not good for the battery. Definitely, the cells will be affected. You need to charge up that battery. There's a lot of loss, self-discharge. There's self-discharge loss, and I believe it is self-discharge because when it's disconnected, it can be at 90. So self-discharge up to this moment. So it's not good for the cells of the
As
battery.
it is not used now, can't the battery be disconnected from the system?
Okay, you have a good point. If you, even though if you disconnect it from the system, there will still be self-discharge.
Yes, but to some minimal.
To make it function.
So if it's something you quickly want to fix back, so
Okay.
no. Any other question, please?
Sir, since the inverter is an hybrid,
Yes.
why can't you use that to charge the battery?
Yes, the essence is for it to be off-grid. Exactly. We use it to power all the lightings in the academy before this challenge. So, since it's hybrid, we can actually bring in, maybe take supply from the IPP, but we didn't design for that. We want it to become, the academy is getting power from the IPP already. So, but you have a point, if we need to charge up the battery, but the best thing is for us to fix the panels and have it back.
You can do it. Yeah. Workmanship.
Free workmanship.
Free.
Yes.
So, sir,
So let's get the funding out. Let's get the funding out. You people can. Yeah, yes, that's why we have ACs to regulate the temperature of the battery. But if you don't have AC, that's another point. At least let it be where there's aeration,
Ventilator.
enough ventilation.
There is transformer problem. Give it here. The transformer.
Any other question, please? So, but you can understand, you can see all the bus bars. So yesterday when I was drawing, it looked as if where are the bus bars, but you can see it now. All the positive and negative, all the positive, all the negative. Then one terminal to where?
Bus bar.
Okay, guys.
Sir, this
Yeah.
up. Those 12 volts that you made mention.
No, this is AC.
This
It's AC, but it's 3 watts. 3 watts fluorescent
I
LED.
can see it.
3 watts fluorescent LED. So this energy efficiency.
3 watts. But if I want to better.
Okay, thank you guys. I hope you got value. Thank you. Yo.
Yo.
Yeah. configuration is not the same for everything.
No, controller làwọn eléyìí. Bus bar eléyìí ni bus bar.
So that's why any product you get,
Don't cross the
make
red
sure
line.
you have the manual.
Don't cross the red line.
What's that line?
Cover the plate oh, before you.
Don't cross the red line.
So basically, it's a simple system. You know, if you go to the site, you know what you are connecting. You'll be supervising, and you can put your hand to it. So there's no challenge. The only limitation you have is your mindset.
But sir, I've seen most of these people connecting this solar panel.